Welcome to another episode of the 10-Minute Land Surveyor. I'm Dave Woolley. Today we're talking about least square adjustments. Most people associate a least square adjustment with post-processing GPS. And yes, that's true. That's how we do post-process GPS. But least square adjustments have many practical purposes, even in resolving boundaries. I'm going to talk today about what a least square adjustment is, put it in real simple terms, and then the next episode I'm going to talk about using it for practical purposes. So what are we talking about in least square adjustments? Well, when you take a series of measurements, let's say 100 feet nominally, and you measure that several times and you have a variation in that measurement, what is the best fit of that adjustment? Well, let's go ahead and look at the screen here. Here I have measurements of 100 feet, and each one of those measurements are my measurements of 100 feet. And you'll see I have variations in there. The first one's 100.05, and if you go up, you'll see that we get it all the way down to a 99.69 here, so on and so forth. We took 10 measurements. The average of those measurements is 99.95, shown right here. So that is the best fit of all those measurements. And in its simplest terms, each measurement is equal. We didn't use a better chain or a worse chain. And so in the simplest terms, each measurement holds the equal amount of weight. So we take the average, shown here, and the average is taken from the measurement given. And that difference shown here is a residual. And some are plus and some are minus, and that's the residuals of that measurement. Now, the residuals are squared. You end up with, they lose their positive and negative sign when you square them. And so you have a sum of residuals squared, which is 0.21. You divide that by the number of measurements taken, 10 in this instance, and of course you end up with 0.021 equals, and you take that 0.021 and you take the square root of that, and you end up with your standard deviation. Here, standard deviation is 68% of your measurements will fall within 1500ths. Well, let's see if that's true. I have 1, 2, 3, 4, 5, 6, 7. What do you know? 7 out of 10 measurements fall within 1500ths, as they should, 68%. That is the math. Now, to check ourselves, just here in Excel, you'll see the formula up there for standard deviation, and the standard deviation of those measurements is 1500ths. This is the longhand. Don't write this down. You don't need to know it. It's just to give you a better sense of what a least square adjustment does. Let's take a look at a linear regression or a least square adjustment. Let's say, just for the sake of discussion here, that we have these points here, these points shown as blue circles. And those blue circles are meant to be on the same line. They could be front lot corners, they could be top of curb, so on and so forth. There's no scale, so this could be a 100th for every shot, it could be a 10th. Who knows? Doesn't matter. So what you see here is you see the residual from the line shown here. The residual is actually how far left or how far right the actual measured point is from the best fit line, or the linear regression. And depending on whether it's a plus or minus, really is as simple as what's the direction of the line. If the direction of the line is going left to right, as you see here, then the residuals are positive to the right, negative to the left. If I went the other direction and I went right to left, it would just change the sign on these. That's how unimportant it is. It's just the direction of the line. So if you go through and you look at this here, and let's say that this line running through here now, I have a sum of residuals squared. And let's say that this one is negative 200ths, and this one's positive 300ths, and this one's positive 600ths, positive 300ths, negative 7/100ths, so on and so forth. And what it does is it tests the line through these points. This one, let's say this one was 0, 0, say it fell on there. So when it comes through, whatever line fits the best going through here, let's say that this is the line, let's say here, that was actually the best fit line. What it means is that the residuals squared are the smallest, hence least square. That's all it is a least square adjustment is just saying that this solution creates the smallest number of residuals squared. Interesting, right? So the program, if you're running a program and the program runs through and you see it comes up with a line, it's the least square, it's just saying that it makes the residuals the smallest. Now, you always have an option to remove a point like this point here because it just doesn't work. So you could remove the point, that would reduce the number of residuals squared. You do not want to reduce a point unless you can identify, all points being equal, unless you can identify a reason to remove that point. You can remove enough points, you get down to 2 and you have no residual squared. So you want to be very careful when you do an least square adjustment that not to remove measurements unless you can identify a particular blunder. So the program will do one line, as you see here, it'll test it. And then the second line, it will test it. And let's say that the first test comes through and it's right here. It comes through, it does the sum of residuals squared, and it says that's a baseline. It comes through again and it tests this line, and it does a sum of residuals squared. And now it compares. It says, okay, that's my least square. And then it'll do another one. Now, if you're doing a least square adjustment, just so you know, each time you see that adjustment say iteration, each one of these potential solutions shown here are iterations. So when you see an adjustment going through iterations, it's testing solutions. Now, this is a line solution. You can do a point solution, and you can do a network solution. But it all is the same. It's testing to try to hold those measurements in a surveyor's sense to the least amount of adjustment required so that you have the smallest residuals squared, least square, and that's your solution. Now, when you see your iterations going up, it's having data, it's having a hard time fitting the data into the parameters that you have given it. And it walks those solutions in kind of like a mortar. Like it tests, 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 and then it says, okay, each test I go through, I'm not yielding any residuals or results. And you'll usually have to set a parameter in there and say, you know, when you get down to 100th, don't try to do any better, cap my iterations. And so when you do an adjustment, you say, this is what I expect. Don't do any more iterations after you reach 100th on a network solution. And that is, my friends, least square adjustment. I'm going to give you the longhand formula of what was happening on the Excel spreadsheet. And this is what the longhand formula looks like. This symbol here is the sigma symbol, lowercase. This symbol here is the uppercase sigma symbol, which means sum. This is the symbol that you use for standard deviation. So when you say it's 1 sigma, it's the lowercase sigma. Uppercase sigma, x is residuals, squared, we all recognize that, divided by the number of measurements, and then you take the square root of it. Let me show you. I took my residuals. My best fit was an average in this case. I came up with my residuals, which is just the difference from my average to my measurement. I squared them. I totaled them, big sigma here. Summed them, divided by 10, came up with 0.021. I did a square root, and I end up with the standard deviation. Now, to check myself, I just went in, and you can see the formula shown right up here. The highlighted box is shown here at 1500ths, and there's the formula in Excel that shows you what the numbers I took. I took B2 through 11, said give me the standard deviation, 1500ths, checks my longhand work, and that, my friends, is least square adjustment. Easy peasy, everybody can do it. It's time to put away our clown shoes, pack away our mini bikes, and take up some least square adjustments. Thank you to everybody who has taken the time to send me emails and to comment on the videos. I really appreciate it. The Orange County chapter appreciates it. Have a nice day.